Hello everybody, this is Michael Shakib from Swansea University and Project Metal, and today I'm going to go on to the final video of the mean linear intercept method and talk about how we can do it using a free bit of software called ImageJ. Distinct advantage of ImageJ over some other pieces of software is that it is absolutely free, so therefore it's accessible to anybody. So I'm going to go ahead and open it up, and when you do open up ImageJ, you'll see a fairly sparse user interface. Okay, you're not going to get much from this software in terms of a flashy user interface. Okay, so once you've opened up ImageJ, this is what you're going to be dealing with here. So I'm going to go ahead and click on File and Open, and I'm going to open up Desktop Microstructures. I'm going to open up the image that we've been using in the previous two videos, and it's going to be this one here. Okay, there we go. Right, so what do we need to do? Well, we've got a lovely clear image of a polycrystalline grain structure. In this case, it's titanium. We have our mag bar. So what do we need to do to do the mean linear intercept method? Well, we need a test line, right? And we need to know the length of that test line. So first of all, let's go here and draw a straight line. All right, let's draw a straight line anywhere. Now, I don't know whether that came up there. I'll do it again. Yeah. Oh, it doesn't appear, but up there underneath the bar there, it says length test line. All right. Now we can't trust that length at the moment. We don't because the image is uncalibrated. So what we need to go and do is calibrate this image. So we need to tell ImageJ how long this test line is in relation to our mag bar, and it's quite easy to do. So if I go, first thing I'm going to do is zoom in to our mag bar. Okay. You can do that by pressing the positive key, or you can do it by clicking on the screen there. So I'm going to positive and negative key. Oops. I'm going to go back out. Like I say, I don't think ImageJ is the most intuitive way. Bit of software, but anyway. So what I'm going to do, I'm going to hold down the shift key, and I'm going to drag this test line across, and I'm going to try and get it as accurate as possible, so the length of this line lies in between the 500 micron mag bar. Now if I go to Analyze and Set Scale, okay, what this is telling me is that this line here is 348 pixels in length. Now that's not good to us. We need to have that. We need to have a known distance. Now we know the 348 pixels in this case, in this particular image, is equal to 500 microns. So for the known distance, we'll type in 500. And what's our unit? Well, I don't think it really matters that much, but we'll type in microns because that's our unit. Okay, we'll click OK. Now if we went and drew another test line here, alright, there. And if I go to Analyze again and click on Measure, there we go. Now we know we have a set scale, so we know that this line here is 500 microns. Now this is great. Now what we can do is now we can go ahead, if I expand this image out a little bit more, yeah, you have to keep everything sort of in view, otherwise it will just cover it. If I go and expand this image out just a little bit more, I zoom out. Right. Now we can draw a test line anywhere on this image, and we can measure anything. Now this is why I say, this really, that's all we do in is the same premise as before. This is just an on-screen measuring tool, and it's been calibrated using a set measurement distance, in this case 500 microns. So you can do this with any image you want. And I know people use this software for all sorts of scientific things, measuring. I think I've seen a report of people measuring small capillaries or blood capillaries in lungs and stuff like that. Anyway, that's a different subject. So now you see I've drawn this test line, and if I go and click again, Analyze and Measure, I should get a second measurement here. It says 2,441. So that's the length of this test line. Now you can go ahead now and you can start counting the grains. Yeah, and if you don't know how to do that properly, you need to watch the first and second, well, not the second video, the first video on the counting method of how to count these grains. And if you watch the second video, you'll see that I put up an Excel spreadsheet, which will enable you to give you some sort of order of counting. Now that's how you do it. That's basically how you use ImageJ to calibrate an image, put a test line on, find the length of the test line, count the number of grains, and find your mean linear intercept method. Well, find your mean linear intercept length, which is indicative then of your grain size. It might be handy at this point to actually go and perform the mean linear intercept for this image here. So let's go ahead and do it. So I'm going to expand it up a little bit more so I can see what I'm doing, and then get the grains to be larger and more clear. Right, so I'm going to go and draw a test line. In fact, I'm going to go in a little bit more. I'm going to draw a random line of known length. And how do I know the length? Well, so all I've got to do is go into analyze and measure. And there's a length, 914. So what I'm going to do is put that into my table here. 914.3. Alright, now let's hope this works, because it's sometimes quite difficult to count. So actually what I'm going to do is put some dots. If I use this tool here, I'll change the color to white, close, and I'm going to put dots. I need to go in a little bit further actually to get more resolution. So let me expand this out a bit more and use this hand tool to move across. Right, I think that's probably the best thing I'm going to manage at the moment. Right, so there's one boundary there. There's an obscure one there. There's probably two there, a very small grain. That might throw the measurement, but I think there's another. That's very difficult to see. You can start seeing the limitations of this. This is a triple point. Another one there. I'd say that's a triple point, although, you know, you may argue it's not. And there's another one there, and there. And that's a grain boundary. That's a triple point. Here, here, and here. And we've terminated within the grain, so we don't count that. So how many white dots have we got? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So I'm going to type that in there as 13. You could argue this. This can be quite subjective, as you've just seen. So I'm going to change the colour of the pen now, and I'm going to go hunting for. What colour shall I make it? I'll make it orange. And we're going to go hunting now for triple points. Right, well there's none here, none here. There's a triple point there. Let's say there's one here. One there, perhaps. Yeah, and that's it. So we've got 1, 2, 3 triple points. So I'm going to type 3 in there. And if we look at what is P, well, P is the number of whole intersects plus the number of triple points, which is the number multiplied by 1.5 as seen in this test standard. So we have a mean linear intercept length of 52.25, which isn't far off what we had before. And of course there may be some conjecture here as well with counting. So there we go. That's how you may want to perform the mean linear intercept method with ImageJ. You can do it this way, but I did find a feature the other day that makes it slightly easier, because otherwise you have to, you've got a different length of test line every single time. If you click on this here fixed length tool, all right. Now this line gives you a fixed length. Now if you double click on the fixed length tool, and if I typed in 500 microns, okay, and drew another one, now this line should be 500 microns. And I think if I click on there instead and sort of spin it round, we can see that it does equal 500 microns. Now that's great. So that means that we can put a line of set length anywhere, I'll say 2000 microns, anywhere on our image. It's a bit difficult to deal with, but as soon as you get it, it's great. Do your linear intercept method, move on to the next, click on somewhere else, do the next one. It's a really, really handy tool. Once you get to use it, I think there's loads and loads of different functions in here that people use. And you get add-ons, and it's a free bit of software. I think people are improving it all the time. So if you have any questions on anything more on using ImageJ and the mean linear intercept method, write in the comments below or send me an email. Thank you very much.